All right, let's go ahead and get started. Hey everyone, this is Mr. Younger. It's about 11 a.m. on Thursday. I am doing an introduction to our week 2 lab for Physics 241. This lab is called Motion Detector, and it's online assisted. So basically, we created this during the COVID pandemic because we really had no choice of any way students could actually attend class. So what we did was took a large fraction of the data ourselves and videoed it and then allow you to analyze that by using the regular document that we use for the motion detector lab, but with an addendum, as is basically the way we do all these labs in this online 241 classes. We have an addendum in addition to the regular lab report write-up, and the regular lab report write-up tells you how to do the original lab that we would have done in class, and then we'd have an addendum which tells you how you can do it on your own. So just remember that that's the way this lab works. In addition to that, we offer various videos. In some cases, just videos of the labs being run. In some cases, it's videos about very specific parts of the lab. Or in some cases, it's like this, where I'm just introducing you to the documents that are available to you and the files and stuff of that sort. So let me go ahead and start now by showing you the page. I've done some things that are a little different than they were just an hour ago. Specifically, the individual modules for lecture got a little too crowded, so I'm going to start having week one module that's for the lecture, and then right under that it'll be a week one, and then it'll say week one lab module, and then it'll have the same dates as the week one module did, and then the same thing for week two. We'll have the lecture one and then the lab one. So let me go ahead and show you that by sharing my screen. Okay, so right now you're looking at my screen. This was originally what week two looked like. Notice I haven't done week one yet. I don't know that I will. I probably will just to make it consistent so that I could use the course again later. But the main thing is I wanted to do this week's because it just got so full, and students sometimes get intimidated when they see a full module, even though this all these videos at the top are, always optional. I highly recommend them, but they're optional, so it's not like you have to do it. Anyways, here's the week two module. Notice it has the same date, January 19th to 11:59 on January 25th. This is last year's motion detector intro to lab, our introduction to the motion detector lab, and you can see I did it almost the same day to last year. It was 125 as opposed to 122. Of course, I now have a new domain name for my YouTube channel, so I went ahead and changed that. But this is a direct link to the YouTube to my YouTube channel, the specific video about this lab. What I have noticed is sometimes when you guys choose to push this, it doesn't always pan out like it's supposed to. So when I hit this, for instance, it's going to say refuse to connect. What you then do, again, this is on a Zoom video, so y'all won't have to actually hit a link to see it. But right up here is this little box. You can click that. I just left mouse clicked on that, and you'll see that wonderfully luscious full head of hair that I had last year. Anyways, so this is the lab discussion, lab intro last year. You can see it's 39 minutes, 13 seconds. But the main thing is I just wanted to show you one, how we can get to it, and then two, I wanted to show you specifically when you click on a YouTube link within Canvas, it doesn't immediately pull the window up, so that's a bit of a problem. I explain that to everybody in lecture and stuff like that, but it sometimes it just doesn't get across. So, anyways, let's see. Oh, here I am. So now I want to go back to the original page where I was at on my Canvas page. So this is where I was. Now I'm going to go back to modules. So just a reminder, when you do click on that, uh, a link for within my YouTube channel, so a link to my YouTube channel, for instance, like this one or any of these up here, again, what happens is it opens up a window, acts like it's not going to work, but then you just click either that or this little button here. I think either one of them work, but I've always pushed this for some reason. Uh, Anyways, so that's the way you navigate to my YouTube channel from Canvas. And as I said, here's the documents we need for lab. This is the actual normal write-up that you'd have whether you're taking the class face to face or otherwise. And it is in Word format. You can see docx, so you're allowed to download that. And then in principle, you're supposed to fill out this document. That's the way I'm doing my labs so that it's basically paperless. You can go in and fill out all the stuff. What you're supposed to do, as I've mentioned numerous times and put in the syllabus, is anywhere in this text as you're reading, if you see a question mark, that means there's a question been answered, and what you would do is then click next to the question mark, hit return, return to return 3 times, and then in the middle of that white space, type in your answer in some font other than black. Okay, I suggest like a medium blue or a medium green or even a dark green. The main thing is I want it to be, if it's typeset, meaning if you typed it in as opposed to handwritten, I want it to be easily distinguishable from black so that I can immediately look in the document and know what you wrote versus what was in the lab report. So just do that as you're going along, reading, following the instructions, following the procedure, so on and so forth. And then it'll have various places where you're supposed to answer questions. You're supposed to answer those, like right here. The faster of the two trials is steeper or gentler. So you circle a right answer, and that's basically how I'm going to assume it. So if you do anything to obscure one answer, that answer is going to be assumed to be your right answer. So if you do multiple ones, I'm just not going to count it as if you got it right at all. And if you mark out, for instance, what you think is the wrong answer, I'm going to give you the opposite credit and basically act like you got it wrong. So be careful with that. You will be making these graphs. Feel fine to try. I want you to feel like it's okay to go ahead and fill in these graphs electronically, but that normally makes for a really crappy looking graph unless you have some really nice tools to draw on documents electronically. So it's not unreasonable for you to take a photograph of that or just draw that on a piece of paper and then draw the graph that you're predicting or the graph that you actually expect or the graph that you actually saw, and then take a photograph of that and completely replace it or immediately below it, enter it. You can keep it there. The main thing is if you're going to replace it, it needs to be exactly the same. So if you took this one, which is supposed to be distance versus time, it's missing the E there. If you took this out and replaced it with a velocity versus time, that would be a problem. So I want to see exactly what was there, and sometimes it might be best for you just to let me know what was there by clicking, let's say, right in this to the left of this word in, and then hit return, 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 return a bunch of times, and then paste it right below there, your drawing of the graph. I want you to do that on all of these. Here's a distance versus time and a distance versus time. This is a predicted, so you're supposed to predict that a priori, and then after you see it, tell what it really was, and make sure that you make some sense of it. Make sure that you, for instance, got it right. You figured out what's wrong. It's perfectly fine for your predicted not match your actual. That's sort of the nature of a scientific hypothesis. Is you make a hypothesis, and to be honest with you, a lot of times you learn more from the hypothesis being wrong. So don't think that I'm going to take off because you got your hypothesis wrong. That's not going to happen. So when you're doing stuff like this, I want you to just be honest and stick with the original answer. Later on, you'll find in some of these labs at the end, we'll have quizzes and questionnaires and stuff like that. Like this one, I think this is where it starts. No, this is just the regular lab part. That's just the regular lab part, as is that. Keep on going back. Hold on a second. And there's a summary. So here's a summary, but at the end of the summary is something that's sort of like a quiz for you guys. This is the place where I want you to try to get right answers. Uh, and if you learn what the right answer is, I'd still prefer you not to correct it because it's best to know exactly what you got. But you're going to answer all these questions, and these are very much like a quiz, and they're very much trying to ask you whether or not you learned, or they're actually trying to ascertain whether you learned what you're supposed to from this lab. So if later on I give you a comprehensive lab final, which is, one of the things that can happen if I find out that students generally are not all working on their lab. In the online setting, it's almost impossible for that to happen, because basically every student turns in their own lab report, and almost no students have any lab partners. So there's no way you can rely on the work of your lab partner. But if I see a lot of stuff where it looks just like old lab reports that have been done in the past, meaning like literally somebody might have copied it, that would be a good indicator for me to say, okay, hey guys, it looks like you guys are copying some old lab reports, or each of you are copying one particular old lab report. That's a problem. I'm giving you a warning. And then if that isn't heeded, according again to my discretion, if I feel like it hasn't been heeded, then I'll say, okay, and I think I said by 3 weeks before the end of the semester is what I put in the syllabus. I will let you know, okay, y'all didn't follow my instructions, so now we're going to have a comprehensive lab final, and your grades go from 50% attendance and 50% lab report average, with one of the lowest labs dropped, or the lowest lab dropped, to 34% of your lab grade will be this comprehensive lab final that has a history of being a bit of a widowmaker, meaning specifically I usually get out of a class of 24, uh, two or three of my best students maybe making an A or a B, and then everybody else getting really, really bad scores of D is the best case scenario, but normally really bad Fs, like 20s and 30s. So you don't want that. In addition to the 34% of the lab grade being that comprehensive lab final, then you're going to have 33% is due to your lab attendance, and 33% will be due to your lab report average, again, after dropping the lowest lab report grade. So make sure you fill this out, answer all the questions, and notice it says one or more, for instance, here. So you're supposed to select all that are right, and so on and so forth. But this is the lab report you're supposed to do. But you're supposed to have a motion detector to do it, and obviously we can't, send each of you a motion detector, which is a, fairly expensive piece of equipment. So the way we do it is we filmed a lot of it. We gave you data for a lot of it, and we've put them all on this particular lab module. So let me go ahead and go back to the lab module now that you've seen the document that you're supposed to be filling out. So again, you're going to download this by clicking on this little button up here. That'll give you a Word document. You can fill it all in as you've been explained in labs. But to make it work in the online setting, you have to then read the addendum. So here's the document I just read. There's the last video from last year that I did on this one, sort of like the video I'm doing right now. And here's what the addendum says, and it's got a typo in it, but I think you can make sense of it. Lab 2 motion detector. This lab will follow the lab book exactly. The only difference is that you will be given the graphs for each section instead of producing them yourself. On procedure 4, so this is where the typo is. On page 4 of the lab, please attempt to predict what the graph will look like before looking at the graph that is included. So that's why the word stop is in there. They really meant to say on procedure 4, on page 4 of the lab, stop, and then please attempt to predict the graph. That was literally the question that I just finished showing you on the lab report, where it had predicted and then actual. That's the very step they're talking about. So now let me go back and show you, and you can download this document too, but this one's not to be turned in. The other one's what's supposed to be turned in. So I'm going to go back to that module again, and now you've seen where the video is, where the document you're supposed to alter and turn in is. Of course, remember you're supposed to put all the stuff in it and save it as a PDF with a very specific name and then upload it. These are the comments that I've written in the past to students turning in their lab reports. So these are opportunities for you to look and say, oh, wow, Mr. Younger said this to some students and this to other students. Let me make sure I didn't make any of those mistakes. And I've actually got two sets of them. They're just straight text. So all you have to do is just open them up and look. And if you see anything that I wrote in these comments that you might have done incorrectly in your lab, then by all means fix it before you turn it in. I should have your lab one graded probably by Monday of this week, of next week, and then you can start seeing how from one week to the next how your lab grade's affected. But these comments will prevent you from having an initial low bad grade for a lab. This is where you turn it in. Notice I have changed the date to January 29th. I know one of my students had sent me a text message that I saw before I came in to this Zoom meeting. But let's look at this version then. Lab 2 motion detector. Okay, these are where your actual data is. And you can see it's only 3 minutes and 9 seconds long. Lab 2 motion detector. Start off standing about half a meter away from the detector and not moving. There's a nice horizontal line, zero velocity. Next, I'm going to walk back at a constant slow speed. Stand still for about a second and walk back at a constant slow speed. That nice diagonal line, you'll notice. The slope of the line indicates the velocity. Next, I'm going to start back some distance from the detector and walk in toward the detector. You're supposed to get bumps and wiggles along the way, but that's okay. So you can see how this video comes in handy. It shows you specifically how the videos are made. You can see this is a distance versus time graph. You can see when the line is horizontal, that suggests the height, the distance above this horizontal axis to a single point on the data on the graph is the distance away from the detector when you're doing a distance or position versus time graph. Later, we'll do velocity versus time graphs, and of course, the height from the horizontal axis up to or down to a point on the graph. In that case, will represent the velocity, and of course, if it's above it, it's going to be a velocity that's positive, and for the detector, that means moving away from the detector. And if it's below it, it'll be negative, and that means it's a velocity towards the detector. Those are some of the things you're supposed to learn from this lab. So let me go back to the modules now that you've seen this. That's an explanation of how we actually made the data and the graphs that you're looking at. Then I've included the individual graphs, walking away. This was walking distance versus time two. So you'll see there's a number two that they're asked for. Walking distance versus time graph, fast and slow away, and so on and so forth. All of these are different graphs, but they're all in Word documents so that you can readily see them. And you can, of course, cut and paste them into our own Word document so you'll have a record of that. So that's really it. That's what you're supposed to do for this lab this week is you're supposed to make some sense of the data and learn exactly what and these are the specific graphs, what a position versus time graph or a distance versus time graph, they're more or less the same thing, what a distance slash position versus time graph looks like for various types of motion, what a velocity versus time graph looks like for various types of motion. And I want you to stay focused on answering these questions. So, might want to take some time to pause this, get your paper ready, and then write these questions down. So, on a position or slash distance versus time graph, that means position or distance is on the vertical axis, time is on the horizontal axis. on such a graph, what is the distance from the horizontal axis up to, or in principle, it could be down to, but that doesn't happen with the motion detector. But what is the meaning of that distance, that vertical distance from the horizontal axis to a particular dot on the graph? What does that mean? Another question is, what does the slope of a particular point on a position versus time graph mean? What does it mean when it's really steep? What does it mean when it's really gradual? Or like this, and what does it mean, period, in terms of the slope? What physical parameter does that apply to? Now you ask exactly the same questions for a velocity versus time graph, only that one allows you to go below the axis even with the motion detector. So again, what is the vertical distance between the horizontal axis and a dot on the graph? What is that on a velocity versus time graph? Additionally, what is the slope of a portion of a velocity versus time graph at any particular part? What does that slope mean? What's the difference between a steep slope and a gradual slope? What's the difference between a steep positive slope and a steep negative slope? What's the difference between a positive slope and a negative slope? Those are the major questions that you're supposed to figure out based on what we've learned a little bit in chapter 2 already, but also as chapter 2 goes on, which we'll be covering more. So make sure you're able to answer those questions, and then make sure that you're able to do the summary questions at the end. The next lab, analyzing motion, will have another similar type summary at the end, and I think that one we call a quiz. But those are indicators of whether you really understood the lab, and those are the things that you want to be really good at if you wish to do well on a comprehensive lab final. But let's hope that we don't have to do a comprehensive lab final. Feel free to exchange information with one another. I think I'll open up a discussion board so you guys can post stuff. I don't mind at all you comparing your graphs and comparing your data or whatever and stuff like that. And I want you to talk about the answers. I just want you all to take proper advantage of that. Like if someone gives you a right answer, yay, that's good. You're gonna not lose some points possibly, which I don't normally grade too much on wrong answers versus right answers, except when it's in a summary or a quiz type thing. Uh, but the big thing is if you're quote unquote using taking those answers and not learning from it, then you're just shooting yourself in the foot. Whereas if you're taking it and learning from it, I don't care at all. It'd be wonderful. I don't mind my students doing what they might think is cheating as long as they're taking it seriously and trying to learn. So you want to not only get an answer, but make sure you understand why that answer is that. And that's where your fellow students can become very, very helpful on that because they can possibly explain it to you better. And that's a whole, paradigm within education is something they call peer instruction, so that your fellow students are often in a better position to explain something to you than your instructor. I try to be such an instructor that I can do just as good, if not better, but I'm sure I fail at that. So, anyways, this is your lab for this week, and as always, your lab's always due by midnight a week from from the day of the lab. So today's Thursday, the 22nd. 7 days from now will be the 29th. That means your lab is due by 11:59 p.m. on the 29th. If we happen to have a day off due to some holiday or something in the next week, then in general the lab would be due 2 weeks later. But the main thing is it's always due the next time lab meets. But it's normally by the beginning of lab class, which I always hold this meeting at 11. But in our case, we're going to make it by 11:59 p.m. That's because everybody could actually look at this at any time on a Thursday and not necessarily even on a Thursday. So it just gives them a little bit extra time. So please take that seriously. There was something else I was going to say, and I think I just lost it. But I guess the main thing is just make sure you get this lab done. Uh, Oh, I remember. Some students had inquired about me doing this late in the afternoon on Thursday, which might be better for students because I might get a few more students to be able to attend. This time I have zero students. And I wanted to do that, but I really can't fit it in at the times that a couple students requested it because my class starts at 5:30 p.m. and they were wanting me to do this like 4:30 somewhere around there. That only gives me an hour, and right now you can see this is going to take less than an hour, but it's not always going to be the case. So what I think I'm going to do, and I'm making this announcement here so you guys will hear it and learn it. What I think I'm going to do is I'm going to continue to do the lab intro at 11 a.m. on Thursdays, but I'm going to try to log in by 5 p.m. instead of 5:30 p.m. For my quote unquote office hour slash class. Now, 5:30 p.m. on Thursday is my PHY 242 online classes lecture, but they don't start till 5:30, so I can get here at 5, and at least y'all will have that uh, 30 minutes to ask me any questions you might have regarding the lab or regarding lecture material or tests or mastering or whatever. So keep an eye on that. Try to be there if you can. If you can't, again, it's all optional. This is PHY 241N02B, and the lab meeting was to be announced, so I can put it at any time I want, and I just make sure it's available to you guys. So feel free to attend or not to attend if you can't fit it in, and feel free to set up an appointment with me via Zoom or even on campus. So I think that's it. I'm going to go ahead and stop sharing the screen. Everybody sees everything you need here. Remember, this is your document. This is another introduction to this lab that I did before. This is the addendum that helps you implement the document without being in an actual lab setting. These are comments that you should go over before submitting your lab just to see if you might have made these careless mistakes, and it'll prevent you from losing 5, 10, 15 points. This is where you're ultimately going to turn in your document as a PDF as instructed in lab uh, on the syllabus as well as in previous lectures and labs. Uh, Down here is your motion detector video, and down here are a bunch of video files where it shows graphs that you can use for labs. So let me stop sharing and say bye bye to everyone. Bye bye. Again, give me a text message or a phone call, or probably not a phone call. If you need to talk to me by phone, we can set that up. It's just I'm not going to be able to answer because my phone's set up not to answer numbers that aren't in my contacts. So if you wanted to contact me, you'd first have to text me, and then we could set up a phone call and you call me. But you can still send me text messages or emails and set up formal appointments that can either be done by Zoom or on campus or somewhere. So thanks again for those of you who are watching this, and have a great day and a safe weekend. Looks like we're going to get some serious snow possibly. So keep an eye out for that and stay safe. Bye.